In this topic, we're focused on energy consumption. And so when we think about the consumption of energy from around the world, it's not evenly distributed. The amount of energy used by the developed world versus the developing world is quite different. And if we think about economies as they move through the demographic transition and industrialize, that typically means those countries are going to be utilizing more energy. They're going to have higher requirements for energy as their economies shift through that demographic transition. And often what that means is their reliance on fossil fuels increases over time. And there's different factors that influence which energy source is used in different areas. A large one is availability, that countries more typically will use energy sources that are readily available close by. The price of different sources of energy are really important, but there's also government regulations which can impact how energy is used and which types of energies can be used. And so if we look at this graph in the lower left, what we see is a graph that shows what I was just mentioning about economic development and energy use. So this is GDP here on the y-axis, which is generally oftentimes used as a measure of economic development in a country. And on the lower axis, we have energy consumption. So we see that the US, for example, has a high GDP and relatively high energy use. If we look at some other countries, let's say Brazil has a much lower GDP, but also much lower energy utilization. Now this is electricity in this case. And so we see generally as countries grow their economies and grow their GDP, that typically comes along with increased consumption of energy. We also will notice that if we look at this graph on the right, this is a graph that shows over time sort of the use of energy and the sources of energy around the world. And so what we see here is we could look at coal as an example here. So over time, coal, which was the first fossil fuels that was really widely utilized, coal increased. But as we get into more modern times, there's starting to be a decrease in the amount of coal. We can look at crude oil, which is this bluish bar here, which has grown pretty significantly. Natural gas has significantly grown and now takes up a large percentage of fossil fuel use. And then what we see here are the renewables, nuclear or wind. Nuclear is not renewable, I'm sorry. Wind, solar, etc., and also nuclear power, which make up a smaller percentage. But as we're going to look at those fuels, we're going to find that those renewables have been increasing as a proportion of energy use in many parts of the world. When we talk about energy, this is a unit that's sort of heavy in math, and we do some practice and in parts of our labs and on your assessments, you're going to have to convert from one type of energy to another or do various calculations to quantify energy use. So when we look at the units that we typically use for energy, there's a variety of units. The one that we will use most common is the kilowatt hour. A kilowatt hour is the amount of energy it's an amount of energy. It's not a rate. It's the amount of energy expended. If you're using a kilowatt of electricity for an entire hour, that is 1 kilowatt hour. So typically what we'll see is if you look at, the energy consumption of your Xbox or your Nintendo Switch, you could quantify it by kilowatt hours, okay, per year, or how much energy is it going to take to run this device for a year. In my car, for example, which is an electric vehicle, the battery is quantified by kilowatt hours. I think it's a 37 kilowatt hour battery. And what that tells me is how much energy is stored in that battery when fully charged. Other units that are used, sometimes BTUs are a unit of energy we use oftentimes in HVAC, heating and air conditioning, hot water heaters. Stands for British Thermal Unit. Calories are often used on food labels for human consumption. Okay, it's usually shown with a capital C. That's actually a kilocalorie. And then the small c calorie is a unit we often use in chemistry or physics. It's the amount of energy required to increase 1 gram of water at 1 degree Celsius. That's the base unit. We also often will see this unit of joules. Okay, joules is the metric unit for energy, and a joule equals various amounts of these other units, but they can be converted from one to the other. If we think about across the world, and this is similar to the graph that we saw earlier, this is from 2022, but this is where the world's energy comes from. Okay. And what we can see here is coal. It's the largest portion currently. Okay. And then we have natural gas as the second, and then hydroelectric and nuclear are the other large ones that are non-renewables. If we look at renewables, wind is a significant portion of the renewables, and then solar, and then others. In 2022, the renewable energy was about 14% of total global energy consumption, and non-renewables was around 86%. But if we look at these green and red circles, they indicate how these are changing over time. And what we see is much more rapid growth in the renewables than we see in any of the non-renewable categories. And just a couple other ways to picture this. This is in the United States. Okay, this is the energy sources in the United States. This goes from 2001 to 2019. And so if we're thinking about the overall patterns, we see coal decreasing over time, natural gas increasing, nuclear staying relatively stable, okay? Wind increasing over time, hydroelectric pretty stable, and then the other renewables are at the bottom. If we look at New York State, because different areas have different sources of fuel, and what you'll notice if you go back and forth between New York and the United States, there's some significant differences, and you probably pick up on it pretty quickly, but coal is a huge difference. So in New York State, we use basically no coal to generate electricity, okay, currently. We did used to use some coal, but not a whole lot. And again, you could think about the reason for some of this is that there's not huge coal deposits in New York State. Whereas if we look at other parts of the country, we would see coal reaching a higher percentage. So in New York State, in the last 5 years, natural gas is a significant portion. And nuclear, we have several nuclear power plants in New York State providing electricity. And we have a significant amount of hydroelectric power that generates electricity in New York State. And so if we're thinking about the impacts of these various energy mixes is what this is called, we can see that New York has relatively clean sources of energy compared to the overall average of the United States. Coal has the greatest emissions. Okay, natural gas also has emissions, but natural gas burns the cleanest out of any of the fossil fuels. So in New York State, most of our electricity comes from natural gas. Nuclear is zero emissions. It doesn't release any pollution or carbon dioxide when being used. Hydroelectric, also renewable, is a zero emissions means of generating electricity. So the mix of energy source in New York is relatively clean compared to other parts of the country.